Hello everyone. My name is Ali Issa. I'm a software engineer and working as an AI engineer at AEMS.AI. And today we are going to talk about LLM agents and how we are going to use agents inside of Lang. First, we're going to introduce what are LLMs, a quick introduction about them. Then we're going to talk about some prompting techniques in order to understand where the thing starts and why we are using agents. Then we're going to introduce agent and its components. And finally, we will have a quick intro about Langchain, and we will explore more Langchain in the demo that I prepared. So let's start with large language models. So when you talk about an LLM, it's basically an AI algorithm, like a complex AI algorithm, which is based on the transformer architecture. And mainly, for those who don't know what is a transformer, it's basically composed of an encoder and a decoder. And when we talk about an LLM, we don't usually mean models like ChatGPT or Google Bard. There are two types basically of an LLM. We have something called natural language understanding, and these models were trained to convert the text into a best numerical representation and like the BERT model. And this is done using some stacks of the encoder block. Another type of the LLM, it's currently used like ChatGPT, it's natural language generation models like Palm, Google Palm, ChatGPT, Anthropic, Falcon. And basically these models are based on the decoder architecture of the transformer. But we should note that the NLU and the NLG are not strictly presented by an encoder only or decoder only. We have another models like Llama 2, which is a natural language generator model. It is composed of an encoder and a decoder. And how LLM works. So basically, especially during inference, we have something called incremental generation. So whenever someone is asking a question, this question is going to be given as a prompt to a natural language generator. And what do you mean by incremental generation? So based on this input, the model will start generating one word at a time. So this word will be added to the initial input. Then this input combined will go another time to the natural language generator in order to predict the next word. So to conclude on the slide, we are just predicting one word at a time, where each word is concatenated to the initial input. Okay, so now let's start with the prompt techniques. One quick note, when you are using prompts, you need to pay attention of the type of the model you are using. We have pre-trained models and we have fine-tuned models. Regarding pre-trained model, these models are not trained to understand the human. So for example, I was using the Da Vinci model from OpenAI. So if I asked him, rephrase the provided statement enclosed within triple quotes, how are you today? It'll start generating the same word several times, which is not normal. So the model is not able to understand my instruction, and this is normal because the type of data set that these models were trained on is not based on instructions. They are just generating the next word based on some probability. So to let the model follow our instruction, we need to perform something called instruction fine-tuning, which is basically preparing a data set composed of some instructions and an output. And during this fine-tuning, the model will be able to follow our instruction. So a small example, I repeated the same input with ChatGPT. I asked it to rephrase the provided statement enclosed within the triple quotes, how are you today? And the model was able to return the correct answer, which is, how are you feeling today? And this was just a quick note to pay attention and differentiate between pre-trained models and instruction-tuned models. And concerning prompting techniques, this prompt is zero-shot learning. And it's basically, we just give the prompt without any additional help. It's just a simple question. But what happens if the model was not able to understand our intent, like our intention, our instruction? What do we need to do? There's something called few-shot learning, where we add to our question few examples to let the model understand how to behave. So, for example, if I'm working on a sentiment analysis task, and we are assuming that ChatGPT was not able to predict the sentiment of a given word, so I created a prompt where I added, for example, I love this product, it's fantastic, and I labeled it as a positive statement. And also, this is a one shot, that's like one example. Then I added another example. This is the worst movie I've ever seen, I labeled it as a negative sentiment, and this is like two shots. So we have two shot learning, which is basically the two examples. And the model was able to predict the sentiment of the next question correctly and labeled it as positive. So this is few shot learning. But what happens if few shot learning also didn't work? We have several solutions. The first solution is to try different model. So the most important part to pay attention to, so for example, if you're working on a coding task, like you're working on a company and you need to work on something that generate a Python code. So you won't choose a model that generate something related to sentiment analysis, let's say. You need a model fine-tuned on generating code. So maybe try to search first for a model suitable for your case before trying any other technique that we will see right now. Another solution is fine-tuning your model. So if there is a rule, if you are using few-shot learning and you added like 5 or 6 examples and the model was not able to give accurate results, then you should go to fine-tuning. But fine-tuning requires more work because you need to prepare a data set. Well, first, you need to have a clear vision of your input and output. And if you have this vision, you need to prepare your data set. You will have a lot of time. And also, you need to pay attention because whenever you are preparing the data set, you are assuming that your LLM won't, the behavior of your LLM won't change in a few months. So in case you want to change the output, you need to change the data set, and this will require a lot of time and cost because you are fine-tuning a large model. So one technique before going to the fine-tuning process is using advanced prompt tuning, like chain of thought, React, tree of thought, and graph of thought, and we'll explore them in later slides. Okay, now what about chain of thought? So for example, if I ask you, what is 2 plus 2? You will directly give me the answer, which is 4. And it's really simple and quick. But what if I ask you to multiply 23 by 27? It's not clear. You need to think how to solve this problem. Like for me, maybe I will try to multiply 23 by 20, then by 7, and combine the results. So I'm thinking in a sequential way, several thoughts. So how can I teach the model to think in this way? So it's really simple. What you can do is to add to your prompt a small word, which is a small sentence, which is think step by step before answering a question. And this question was 23 times 27. And you see that the model was mimicking human behavior. That is, it's like dividing this complex equation into multiple sub equations and then combining the results. And this is simply the idea behind chain of thought, which is decomposing a complex task into multiple subtasks. Now, what about the advantages and disadvantages? So I took this example from the chain of thought paper. So as you see on the left in the standard prompting, when you given a question and given an answer, so this is a one-shot example. You are giving a question and an answer, and then you will provide a question and you will hope that the model will answer in the same way. So this is not clear. The answer is not clear because you are only generating the response without any clarification. So in the chain of thought, which is also one-shot chain of thought, given a question and an answer. In the answer, you are teaching the model how to think. So for example, here, Roger started with 5 balls, 2 cans of 3 tennis balls, and etc. So we are teaching the model how to behave. And based on this example, the model was able to give the correct answer. And these are some advantages. The model is able to perform some logical reasoning. And the researchers said that it's effective for arithmetic and common sense reasoning. But what happens if my reasoning requires factual information? So in this example, they are like looking for a number of rooms in the hotel called for the Cirque du Soleil, and the LLM was not able to generate the correct answer, which is really normal because it's not connected to the internet and the information is outdated. So one of the disadvantages is the risk of fact hallucination, as you're seeing here in the example, and the limited knowledge, which is the same thing. And we have the error propagation. So for example, if you are decomposing the task into like 10 steps, and from the second step, you gave a wrong answer, so the error will propagate, and you will start having some wrong answers. So this is a chain of thought. Another prompting techniques that we have the self-ask, and this is really simple. You will give the LLM a question, and it will start generating a follow-up and an intermediate answer. And the researchers proved that it can outperform the chain of thought. And they also added to it a search engine, so to increase the accuracy of tasks that require factuality. So, for example, whenever the LLM think that we need to have a follow-up question, it will use the search engine in order to receive the answer. Another prompting technique, which is plan and solve, also it's better than the chain of thought. Basically, the LLM creates the steps, then will execute sequentially these steps. So it's not really difficult, simple. Okay, now we're gonna talk about React, and we will see how it's different from the other prompting techniques. So how React works. Let's say I am asking a complex query. And basically React will work in 3 steps. So it contains 3 components. The first component is the thought. So given a complex query, the thought component will decide what it should do and how it should do it. So if I have, let's say, task A, the main task A, it will, the LLM will say, how should I divide the task A, and what should I do? So what should I do? I need to divide it. First, it will not divide the task A into multiple subtasks at a time. It will first divide it into one subtask, see the results of the subtask, then we'll generate another one based on the results. So let's say we divided this subtask, this task A into a subtask. The model will decide to which, how he wants to retrieve the information related to subtask. And then this what and how will be transferred to another component called action. The action will know what subtask it wants to execute and how. The how will be this component will choose the appropriate tool, like the search engine we saw before, and it will execute this subtask and will return the answer to another component called observation. So basically, the observation will store the answer. It's not doing anything actually, it's just a place to store the results of our action. And then the thought component will have access to this observation, and we will repeat the same process. So based on the subtask that I created and based on my result, what should I do? And how should I do it? What should I do? I will create a subtask 2. How should I do it? I might use a search engine or any other tool. But let's say it keeps using the search engine. So this flow will continue until the LLM reaches a point that it's able to return the final answer, and it will be returned to the user. So like, in summary, the React is basically thinking about how to divide the task, how to execute it using the action component, and storing the information or the result of the execution inside a third component called observation. And now let's compare the React to other prompting techniques. So for example, let's go back to the same example. How many rooms are the hotel that is home to the Cirque du Soleil? So first, if I give it directly to ChatGPT, for example, it will return like a random answer. And of course, it will be wrong because it's factual information, and these models are not connected to the internet. And if I use the chain of thought technique, the answer will change, but we will have the same problem, which is where we discussed it earlier. The COT was not able to provide correct answers about tasks that require factual information. And we have another technique, which is act only. Well, I didn't talk about it because like it's not it won't work, because as a human, you always think before you do any action, and the act only, the LLM will only do some actions, like choosing to do an action until like suddenly it achieves a good result, which is really wrong. So what about React? If I gave the prompt to React, first, as we said before, in the thought component, we will decide the what and the how. So what should I do? I need to search the Cirque du Soleil, and how, using the search component. So search is the keyword to use the search engine. So in the act component will take the what, which is the Cirque du Soleil, and how, doing the search on it, and we will sort the results inside the observation. In the second thought, based on the search, they did not obtain any results about the Cirque du Soleil. So the model changed how he wants to perform the search. So he changed from searching the Cirque du Soleil to search Mr. Cirque du Soleil. So based on this change, the model was able to get the appropriate answer about the name of the hotel. And then in the second thought, the main idea is to check the number of rooms. So after the LLM was able to know the name of the hotel, the model performed an action in order to search the number of rooms, and at the end was able to get the appropriate answer. And if you want to talk about the advantages and how this technique is different than the other techniques, because you might wonder that this React technique is similar to self-ask, because in self-ask, we are using a search engine. Here also we are using a search engine. But the main difference is in the traceability and in the explainability, because in the self-ask, you are only using, the LLM is only generating like a follow-up required question answer. Here we are generating the thought, how the LLM is thinking. And we are dividing all the components into three components. Like the thinking will be added to the thought, the action inside another component, and the observation is inside a third component. So traceability and explainability is really important in the React. And we don't see it in other prompting techniques. And also, the React can interact with any other tools. Unlike the self-ask or the chain of thought, the React can connect to not only the search engine, but you can connect it to an API to get the weather, for example, or you can connect it to a vector database to do some information retrieval. Like you can connect it to any tool you want. So now we reach to the agent. So what is an agent after this long introduction about the prompting techniques? So mainly the components of the agent is an LLM, which you all know, the React, we already explained it, and the tools. So these three components combined will form something called an agent. And to better understand it, we have another example, more detailed, about the components of the agent. So first, we have the brain. So basically, it could be a chain of thought, but like it's not a problem. We need some reasoning, so it can be chain of thought. And then we need another thing called evaluators. So basically, we'll not go into details about these prompting techniques like self-refine and reflection, but the main idea about the evaluators, so based on the result that we receive, these evaluators gonna refine the answer, change it in a way that will be more suitable for the model to understand. And researchers said that these techniques will increase the accuracy of the agent. And just a quick note that the reflection technique is based on some reinforcement learning technique. And another component, which is the action, basically we will execute a tool. And you might ask yourself how the LLM will know which tool to execute. Like, as I said before, we can have the search engine, an API, vector database. So we will provide the tools with a description. So the LLM will know when to use each tool depending on the use case. So mainly these are the components, but what about like the memory? How are we gonna let the agent remember what we are talking about? So we have a short-term memory and we have a long-term memory. And the short-term memory, it ensures that we never lose the track of ongoing conversations. It's like the main idea, we don't want to the agent get lost. And we do this by like shifting a context window. So it's like a window that will highlight on the recent conversation to make the bot understand what we are talking about. But what about the long-term memory? So for example, if I'm using a tool that generated like pages, uh, pages of text, what should I do? I will not be able to add it directly to the conversation as a short-term memory. Like it's not a good idea. So we need a way to store them. So a technique that could be used is this whenever you obtain a long answer, you need to summarize it. The summarization will be added to the short-term memory, and the rest of the information will be added, for example, inside a vector database. And what you can do is whenever a user will ask a question, you can perform an information retrieval over this question and search relevant context that is stored in the vector database and retrieve the relevant information related to user query and continue the conversation. So this is mainly the components of the agents. And also I've added some few advanced techniques, reasoning techniques. We already talked about the chain of thought. We have something called multiple chain of thoughts, self-consistency. So the main idea behind this technique is we're gonna increase the temperature and we're gonna explore several paths, and the path that will lead to the best answer, I will choose it. So could be, and this technique is like outperforming the chain of thought technique. Another one, which is the tree of thoughts. And the tree of thoughts, like its name, it's a tree, and we can explore several passes at the same time, and with the ability to backtrack from a chain. So if you're gonna see the chain of thought, when you go inside a node and go like deeper in the nodes, you will not able to backtrack in case this final node was not giving any good results, but it is allowed in the tree of thoughts. And another advanced technique, graph of thoughts, which is better than tree of thoughts and the other techniques. Basically, it also allows backtracking and also it refines the nodes. So if you are in a specific step, you divided the subtasks into several, or you divided the task into multiple subtasks, you can define a subtask, and you also combine the results from several nodes, which is not the case on the tree of thought. So these are just some quick notes if you want to explore them later. Okay, so now we have talked about the agents, but also it has some challenges. So one of the challenges is how can you prevent the model from choosing the wrong tool, and how can you encourage the model to choose the appropriate tool, which is like basically the same. And it could be based on the tool description. You can enhance the description, but what happens if the description is not helping? You may think about reducing the number of tools, because having a lot of tools will decrease the accuracy of the LLM in choosing the appropriate tool. Another reason is same thing, to understand how to use LLM results with different tools. So sometimes we might need to let the agent to use several tools at the same time. So maybe you need to do some tweaking in the agent to let them use several tools at the same time. And how can I manage the memory? So we already talked about the short term and long term, but like in practice, and when you want to code it, how do you want to create the short term memory? How you want to create the long term memory? Do you want to establish the connection between them? So yes, this also is a challenge. And also, how do you want to include detailed observations? So unlike the self-ask, where we don't have any like good observations or detailed observations, how can you encourage the model all the time to give some reasonable observations? And also how to let the model to stay focused on the task, because if you are decomposing a main task into 10 tasks, maybe when the agent reaches the fifth subtask, it will forget what was the main goal of this whole procedure. So this also is a challenge. And also another challenge, which is check and assess how well things are going, which is basically evaluating an agent, which is a difficult part. Like if you want to evaluate an agent, like what are the metrics? What is right and what is wrong? How are you going to evaluate it? So it depends on each use case, like depends on what you are working on, but also this is a challenge on choosing the right metrics. Okay, now I added this slide that you can check it later. It's about the list of open source and closed source models and some specialized agents, like open source agents, closed source agents, and also some frameworks that allows you to build your own agents. Like you don't need to worry about building everything from scratch. You can use some libraries that provide building agents like Langchain that we are going to talk about now. Okay, now let's talk about Langchain. We will have a quick introduction about Langchain before going to the demo. So first, what is Langchain? It's a framework or library. It's designed for creating applications driven by language models. So you are able to create like a pipeline where several LLMs are connected to each other. And also Langchain offers like prompt templates and like chains where you can specify the type of the LLM. Is it used for chat or any other, just for like, if you want to use a chat or any pre-trained model. And parsers, because parsers are useful because you're always handling unstructured data. So you need a way to convert this unstructured data into a structured format. So Langchain provides some parsers to do this. And we have retrievals. Retrievals are like RAG, like retrieval augmented generation, and they are really useful when you have a lot of data and you want to perform an information retrieval over them. They have a lot of vector databases added to Langchain. You can check them if you're like interested in retrieval augmented generation. And of course, they offer agents. Also, Langchain introduced recently LangServe, which is used to like deploy Langchain chains as a REST API. And also they offer Langsmith, which is the ability to debug and test your chains. You can able to see the output of the LLM in case you want to enhance it and check where are the weaknesses. So this is mainly about Langchain, and we're gonna explore the rest of the details in our demo. Okay, so just 1 second so I can get the collab file. Okay, can you see my screen?
Yes.
Okay, so concerning this demo, so as I said before, you don't need to worry about building everything from scratch. Like Langchain provide some tools that allows you to build an agent in few lines of code. So first, you need to install some libraries of OpenAI because I'm using the LLM from OpenAI, like ChatGPT, of course, Langchain, and we are using Google Search, a tool to perform some search, and also Wikipedia. So as we talked before, you need to first define the components of an agent. So first we need to select our LLM. So I've been using the ChatGPT from OpenAI, and I can call it through this function, chat OpenAI. Now, concerning the tools, Langchain offers the ability to build your own custom tool or choose an already built tool, which is provided by them. So the first tool that I built is a math tool. Well, actually, I built the input parameter that this tool will take. So, for example, I created math calculator input, which is basically will take a user query. And one quick note about this class. So basically, Langchain uses a library called Bidentic. So Bidentic will allow you to create a class, and it will automatically convert it into a JSON format. And this JSON will be the shape of the input required that will be used by the math tool in order to execute the function. So by this code, like you can create or you can add this input parameter inside this tool from function. You can specify what type of tool you want, which is LLM math chain. I gave it a name, which is calculator, and I gave it a description. As we discussed earlier in the previous slides, you need to add a description to the tool in order to know which which tool you need to use. Okay, now the other tool was the Google search tool, which is I already used the predefined tool from Langchain. But first you need to create an API key. You need to log into the Google account, like Google search account, and to create an API key and pass it here to the tool. And the third component, which is the React, which is basically the prompt. And I printed the prompt so we can better understand how all of this is working. So basically, in the prompt, we will tell the model to answer the following question based on the following tools. And each tool, the tools are the math tool and the Google search tool. And the Google search tool will have a description, the math tool will have the description, so the model will be able to choose the appropriate tool based on the information provided by each one. And then we will tell the model that whatever tool you have chosen, you need to return a JSON object containing the action, which is the tool name, and the action input. So for example, if I'm using the math tool, I want to, for example, if I'm using a math tool, I want to ask, okay, just sorry, 1 second. Okay, so if I'm using the action and the action input, the action will contain the tool name, the action input will contain the input, which is basically in case of a math example, the name will be a calculator, which is provided earlier, and the input will be like, for example, 23 times 20. And this action will go to the action component that we previously talked about. So the action component will take the name and will take the parameter and will pick the appropriate tool. And here are some details on how to prepare the prompt in order to finally provide it to the agent. And here a quick note about the syntax. It's called Langchain expression language. So this Langchain expression language is like similar to Linux. So and the way they wrote it. So it's a simplified way to build your pipeline. So basically you say that you are having an input, you're going to provide it to this that will have this prompt, and you're adding this chat model will stop. So you don't want the model to like start generating answers all the time. So you need something to make it stop. And we have some parsers that we talked about earlier to convert the unstructured data to structured data. And finally, you want to build this agent. So you specify, we are using this agent right here with the appropriate tools that we created before. This parameter was equal true to like display more information and handle parsing errors. Langchain provides some like tools that will automatically handle cases where you have an error. Because if you want to build something from scratch and you are executing a tool, you need to pay attention if the parameter type was not passed correctly, if something went wrong. So all these cases should be handled, but Langchain offers this parameter that will help you to manage such errors. So I created two simple examples just to understand the concept. So this first one related to like a football question, and it will automatically know that to use Google search. So when I asked what the birthday of the individual who achieved the highest goal count in the Premier League during the last season, uh, the agent divided this complex. It's not too complex, but the task that require multiple subtasks. And in the first part, it decided to search about the individual. And when it was able to know who was the individual, it searched about the birthday about this individual. And as I talked earlier, we have the thought component, the what we should do and how we should do it. What we should do is to check for an individual who achieved the highest goal, and how we should do it by using a search tool. So the action will be passed to the action component, where we will tell him that I want to perform a search using a search tool, and the input parameter will be this Premier League highest goal scorer. And will I obtain this answer, which is the observation. Now, based on this observation, I'm going to perform another action, which is getting the birthday of this player. And based on this second action, I was able to retrieve the birthday, and like the model knew that the answer was returned, and it stopped returning any additional output. Another example, which is related to math. So if I said Sally has 8 candies, she eats half of them. After eating, Sally decides to share 1/3 of what's left with her friend. How many candies does Sally have now? So this task needs to be decomposed. So same thing, the model will start thinking like what I want to do and how we want to do it, to calculate. So how I need to calculate. So the action sent to the action component will be to use the calculator, and action input, which is also given by the thought, as we discussed earlier, will be given to the action component, and it will be executed and stored as observation. And then after we obtain this result, it will be returned to the next step, which is multiplying 4 with the result 4 with the 2/3 in order to indicate how many candies she has now. And the final answer was returned successfully. So this is a main idea, a simple example how the agent can work. But of course, you can build more complex stuff, add additional tools, like I said, virtual data or any API call. So this is the end of this demo. If you have any questions, feel free to ask.
Yeah, thank you so much, Solly. So there is some question on the chat. So let's go with
Yes.
that one. So by Anil Sakotaji. So how does the model decide when to use from external source versus using the trained data to verify the validity of its generated output?
Yes, so the purpose of using an external resource is to check the validity of the generated output. So, for example, you can let the LLM generate the answer, and you can also use an external resource to get the answer, and you can compare both answers to check if the LLM is generating the correct answer. But like mainly when you are using a tool, like you don't want the LLM to generate the response by itself. You need some external tools to get a more accurate answer in order to decrease the hallucination that is caused by the LLM.
Okay. And how does the model decide?
The model would decide which tool to use by giving a description to the tool. So for example, if I have a math calculator, I will say that use this tool when you are performing some mathematical operations. And same thing for the other tools. And you also need to add the description to the parameters, because not only the LLM will choose the appropriate tool, but also need to do some entity extraction in order to extract the relevant context and give it to a appropriate function. And basically the function will take parameters. So you need this mapping from this user query, extract the entities and map it to the parameters. So you need to provide description of the tool and description of the parameters.
Okay, thank you so much. So there is a next question, and you can also ask the question. So I have given the permission to unmute. So you can also ask the question to the speaker. So is that metadata from the output like title, date, etc. is automatically classified by LLM? So there is a next question. Uh,
Can you clarify your question, please?
Yeah,
so
I can clarify. Hey,
yeah,
Ali, thank you for the
Hi.
session today. I do have a follow-up question on the response that you gave earlier today. So
Yeah.
regarding the model deciding when it needs to go outside the external source, like because I was thinking if we were to use a private model within a intranet instead of going internet. So let's say you want to go offline and use that. At what
Yeah.
confidence level do you decide, hey, model, you need to check your work? Is it like every prompt, every response, it needs to check its work? Or is there like certain criteria you decide and say, hey, you need to go out and check your work because there might be a greater chance of error? Like, like I'm trying to understand at what confidence
Yeah.
level do you dictate?
So basically, for example, if you can like force the LLM to always, whenever a user asks something related to a search using the Google search, for example, you can force the LLM to always use this tool. So for example, in some cases, the LLM could use another tool by mistake, but we can force the LLM to choose the appropriate tool. Now, you are saying if you don't want to go like outside, like be online, you want to use the LLM offline. Well, you can use it offline. You can build some functions that will not require for example, any internet connection, but you need to pay attention to something related to the factuality of the answer. So, but if you want some like factual answers without connecting to the internet, you can store something inside a vector database. So we will have a lot of information, store it locally, and you can perform the search locally. And one quick note that you can tell the LLM in case you didn't know the answer, uh, don't use any tool and do something else. And you have the ability to choose this something else. Is it clear?
Yeah, no, thank you. I think that was helpful. I guess I was trying to get like having your own intranet, like your own, like I think you talked about like having the vector database of your private database where you can access. Okay.
Yeah, you can start as a vector database or a normal database, like depending on your use case.
Okay, sounds good. And then my second question that I have put in was, when you were generating the prompt, and actually the output from the agent, I saw that when you were saying, "Hey, give me the day," I guess the date of birth for that person who
Yes,
scored this much. So I saw that
yes,
it automatically, I don't know if that was automatic, like it would automatically tag the metadata like name, date of birth, all of that field like usually we have to generate. Is
yes.
that done by the LLM?
Well, no. So basically, the LLM don't care about the birthday as an entity. It will care
Mhm.
about the name of the person or the query that requires the search to perform the search on, and it will send this name to the tool, and it will receive an answer. So it doesn't care about the birthday as or the date, but you can manually configure, like create a separate tool, and that have like that has several parameters like date and birthday. Like you can manually configure what types of parameters you want to receive or you want to generate.
I think
Uh,
I'm getting, but would you mind sharing your screen with that collab? I think I can better point you if you don't mind.
Yeah. Can you see my screen?
Yes. So if you were to look at the title, like like how it generated title, Eric, Helen,
Yes.
tables, title, is this is what I'm talking about. So is this like it knows what the title is, what the games are, what the leagues are, names. So I see the metadata about the data that it searched from the online. So basically Google told, hey, there's a guy called Eric Helen who actually scored that much. So is that then
Yes.
the agent categorizing it as a putting into separate metadata within the table or like the query, I guess?
Yeah. So basically, this is not related to the LLM. So this is the result given directly by Google. So mm, these entities were not created by the LLM, but Langchain created this tool. So maybe if you want to check the tool in details how it's working, maybe they are converting this unstructured data in a more structured way. But this is not related to LLM. So the LLM is not responsible of creating this metadata. So he is just receiving this information.
Oh, that makes sense. Okay, thank you. Yeah, that's what I was confused. Okay, makes sense.
Yes.
Thanks.
Welcome.
okay. Thank you so much, Anilji. Yeah, and one, I have a question about this custom LLM. So, how can we make the custom LLM in the LangChain? So, any thought on that one?
Custom LLM. Well, yes, you have several possibilities. Langchain provides several agents. They have zero shot React agent, some OpenAI agents. They have several types of agents, and also they offer some open source agents. But if you couldn't, if you find out that none of these agent types are suitable for your case, so you need to go for another open source agent, like AutoGPT, for example. It's open source, so you can go get the code, try to customize it for your use case, and like use it. Just simply use it. But it will require a lot of work because you need to check how the code is working, how to tune it for use case. But before doing all these steps, just do some tests on the current agents provided by Langchain or any other open source library and see if it's giving great results on your use case. If it's giving great results, no need to check a code of an open source model or open source agent.
Okay, thank you so much. And I have pretty much hearing about this reinforcement learning from women feedback, right? So in the Langchain, so in which pipeline we need to add this one, RSLF?
Reinforcement learning
Yeah,
from human feedback, do you mean?
yeah, yeah.
I don't think you can. Well, actually, I haven't explored it, but if you want to fine-tune a model based on the RLHF technique, I guess you can check maybe Hugging Face, they provide some resources on how to fine-tune it. But you need to like prepare a data. So the RLHF technique is based on some data. You're gonna see if some open source data sets are available for your use case. If not, you need to manually create such data and let them people label them and perform this training with RLHF.
Okay, thank you so much. So there is a question: is there a way to fine tune existing LLM to train into different languages? What is what would be the step for it? Okay.
Okay, if you want to find, so basically some LLMs were trained to generate questions or answers in different languages. For example, like ChatGPT, it can answer in different languages, but mainly it's like doing some translations. So if you want to fine tune an existing LLMs to train into different language, so assuming you want, you can, you can, but you need to prepare a good amount of data. But first you need to check if the pre-trained data of the model you want to fine tune contains some it contains different languages. So if not, maybe you need to check if a model that was already pre-trained on different languages, because if they were not, the tokenizer might not work. The tokenizer of the language could be different to another language. So it might work, but I guess you need to try. But it's doable, I guess.
Okay.
Or maybe you can just translate it if you want.
Okay. Thank you so much. So yeah, if there is any question, you can unmute and you can ask to Ali. So I think we are now the end. So yeah, it's been 45 minutes. So thank you so much for the presentation. It was nice. And I hope all have learned about the Langchain as well as about the LLM agent. And hopefully in your project or on your academics, it will be helpful on your career path. So yeah, thank you so much, and thank you so much all for your Miss participation that you have stayed till 45 minutes. And yeah, so we will be doing lots of webinar in our monthly series. Please do attend. So we basically do on the monthly wise, and I hope that we are looking forward for your active participation. And thank you so much, Ali, for the invitation to come on Tech Webinar Nepal Series 59, and we look forward to host Tech Webinar Nepal Series 60. Thank you so much, and have a nice day. Thanks.
You're welcome. Hope you enjoyed it. Thank you.